Hello, today I'm going to show you how to write formulas given the names. So you're going to need those oxidation numbers that we've been talking about on your periodic table. And you're going to need to recall that the sum of the oxidation numbers equal 0. So remember, binary ionic compounds consist of metals and a nonmetal. So if we look at calcium, calcium is in group 2 and has a +2 charge. Fluoride is in group 17 and has a -1 charge. So you can do the formulas with the subscripts one of two ways. You can use the oxidation on the metal and make it the subscript on the nonmetal, and the oxidation on the nonmetal becomes a subscript on the metal, except you don't write the 1, and you have to reduce to lowest coefficients. So since 2 minus 1 doesn't equal 0, that means I'm going to need twice as many fluorines for every 1 calcium. So this ends up being calcium fluoride. All right, let's look at number 2. Barium sulfate. No, excuse me. Let me back up and try again. So this ends up being CaF2. There you go. That's better. Sorry. Okay. All right, let's look at number 2, barium sulfide. Barium is in group 2, so it has a +2 oxidation. Sulfide comes from sulfur, and it has a -2 oxidation because it's in group 16. So since 2 minus 2 equals 0, the formula is BAS. So you can also crisscross the oxidations, but remember, you would have ended up with a 2 and a 2 here if you did that, and that is not in lowest possible coefficients, so you'd have to divide by 2. Dividing by 2 for both ends up with 1, and again, we don't write the 1s. Oops, sorry. We don't write 1. Okay. Potassium phosphide. We have potassium is in group 1, phosphide is in group 15, and has a -3 charge. So I'm going to need to have 3 of these for every one of these. So we have potassium, A3, phosphide, potassium phosphide. Sorry. All right, number 4, aluminum nitride. Aluminum is in group 13 and has a +3 charge. Nitride comes from nitrogen, is in group 15 and has a -3 charge. So this is just ALN. Rubidium hydride. Rubidium is in group 1, so it's a +1. Hydride comes from hydrogen, and remember, when hydrogen bonds with metals, it forms a -1 charge. So it's just RBH, because it's 1 minus 1 equals 0. Sodium sulfide, group 1 metal. Sulfide comes from sulfur. It's in group 16, has a -2. And you can crisscross the oxidations, or you can think, I need 2 of these for every one of those to make it cancel out. And so you end up with Na2S, sodium sulfide. Aluminum sulfide. Aluminum is in group 13, has a +3. Sulfide, we just did that one, it's -2. So this becomes Al2S3 to make them cancel, because 2 times 3 is 6 and 3 times 2 is 6. And then we have a neutral compound. Al2 S3. Calcium phosphide. Calcium is in group 2, so it has a +2. Phosphide is in group 15 from phosphorus and it has a -3. Same kind of situation. You can make the 3 on the calcium and the 2 on the phosphorus, and then they cancel and you got 6 minus 6. Or you can think in terms of 2 and 3 are factors of 6. Multiply that times 3 and that by 2, and you get 0 when you add them together. So you end up with Ca3 P2. Then you have magnesium, group 2, has a +2 charge. Nitride is in group 15 and has a -3 charge. Same situation here. You can cross them, make them cancel. Have Mg3 N2. Lithium oxide. Lithium is a group 1 metal, so it has a +1 charge. Oxide comes from oxygen, is in group 16, has a -2 charge. So I need 2 of these for every one of those to make them equal. So Li, I'll get it right eventually. Li2O, lithium oxide. And those are examples on how to write a formula given a name for binary ionic compounds that are from group 1, group 2 metals and aluminum, and a nonmetal.